So here I'm going to do a quick answer key going through each problem just to practice showing you how to find domain and range since I'm not there. So here we've got a function which is fx equals 3x minus 5, and we're being told the domain of x can be between, or x can be greater than or equal to -2 and less than 8. So this is trying to tell us that x can be in the window -2 to 8. It can equal -2, but it cannot equal 8. So for my range, what I'm going to figure out is what are the lowest and highest numbers that y can be. And in order to do that, I'm just going to take the ends of the x's and put them into the function. So first I'm going to find the value of the function when the input is 2 by replacing x with, -2. And so the value of the function when the input is -2 would be -6, and then -6 minus 5 is -11. And since x can equal -2, that means x can also, or y can also equal that number, which is -11. Now I'm going to do the same thing, but I'm going to find the value of the function when the input is 8. So we're going to build and fill the nest when the input is 8. And so that means that the function when the input is 8 would be 24 minus 5, which would be 19. Now since x can't actually equal 8, that means that y can go up to 19 but never actually equal it. So that would be my range. So now this is asking, first of all, this is telling us the domain. It's telling us what the function equals. This is similar to saying what y equals. I could have said fx over here, by the way, for y. And so when it asks to find the domain, it means I'm trying to find x. And so I'm going to do that by this time replacing the gx with the two numbers that it can equal, or the ends of the two numbers. So if I replace gx with -14, -14 equals -2x plus 6. I'm going to minus 6 divide by -2, and so that means x would equal 10. And since the function can actually equal -14, that means x can also equal 10. Then I'm going to do it with 6. So 6 equals -2x plus 6. That's going to get me 0, and then divide, x would equal 0. Now, one thing that I'm noticing here, just really quickly, is that when I put in these two numbers, this was the minimum value of the function, this was the maximum. I want to make sure these numbers go in least to greatest order. So I'm actually just going to switch where they are. So that means the minimum value x can be is 0, and the maximum it can be is 10. The reason that's happening like this is because we'll do more of an investigation later, so don't worry about this. But I know that it makes sense because of this negative part of this function means that my function is decreasing. So like on a graph, what's happening is the function is looking like this. So as the y values, or the function values, go from low to high, which would be like here to here, so as it goes up that way, the x is going low to high that way. So it kind of makes sense why that happened. Those first two are really just, the point of them is to either replace x or fx with their minimum and maximums in order to find the missing partner x and y values. Now we're going to get into real-world problems involving domain and range. So here I've got a function that says w, which is going to stand for my weight in pounds of a loaf of bread, is going to equal 1/2 f, where f is the number of cups of flour used. So it says you have 4 cups of flour to use. What's the largest loaf of bread we can make? Well, the largest loaf of bread that we can make would happen when I use all the flour, which is 4 cups. And so if I were to do that, that means that the largest loaf of bread would be 2 pounds. Then it says, if the weight of the bread is 1 pound, how many cups of flour were used? Well, I would use that function, and this time they're telling me the weight, so I would replace w with 1, and then to get f by itself, I would get rid of 1/2. I could either divide by 1/2, but remember that the trick to that would be to multiply by the reciprocal, which is 2/1. And so that means that the number of cups of flour used would be 2 cups. which just makes sense. If I use 2 cups of flour, half of 2 is 1, that would be the weight of the bread. Identify the domain and range of the function. So I'm going to go back here for a second where it said I have 4 cups of flour at my disposal to use. So that means the lowest amount of flour that I could use is 0 cups, or the highest amount of flour that I could use is 4 cups. In this function, if I were to use 0 cups of flour, then I'm not making any bread, so its weight would be 0. And if I were to use all 4 cups of flour, I've already done that here, the weight of the bread would be 2 pounds. So what this is telling me is that I could use anywhere between 0 and 4 cups of flour, and as a result, I could expect the bread to weigh anywhere between 0 and 2 pounds. So here it says the temperature in degrees Celsius of the Earth's crust can be modeled by the function T equals 20 plus 25d, and d is the distance in kilometers from the surface. It says the scientists study organisms in the first 4 kilometers of the Earth's crust. So just picture for a second, just to kind of have a visual of what's going on. Picture that you've got the ground here, like the Earth's crust, and the scientist is digging down into the Earth's crust. Every time they travel 1 kilometer, this is telling me that the temperature is increasing by 25 degrees. And what the 20 is trying to tell me is that at the surface, the temperature must be 20 degrees. So when it says that the scientist studies organisms within the first 4 kilometers of the Earth's crust, what they're trying to tell me is that they're trying to tell me something about the distance. So they're saying that the highest distance that they would study organisms would be 4 kilometers, and then the lowest distance would be 0. So if I were to look at this picture, the scientist is studying organisms between 0 and 4 kilometers. So then what we can figure out is what would the temperatures be within those distances. And so I can take these numbers, 0 and 4, and plug them into this function. So if I were to write it over here, t equals 20 plus 25d, I would begin by putting 0 in for d. 25 times 0 is 0. 0 plus 20 is 20. So that means at a distance of 0 kilometers, the temperature is 20 degrees Celsius, which is also what we talked about in this picture. Then I would want to figure out what's the temperature if I go all 4 kilometers into the Earth's crust. So I'd replace d with 4. 25 times 4 is 100, plus 20 is 120. So if the scientist is going to study organisms between 0 and 4 kilometers, the scientist could expect the temperature to range between 20 and 120 degrees Celsius. This one is going to be like working backwards. So now instead of saying that they're going to study organisms between 0 and 4 kilometers, they're saying they're going to study organisms where the temperature ranges between 20 and 95 degrees. So this time we're being told the range. And now we're going to work backwards to figure out what would the distances need to be in order to make that happen. So first I'm going to begin by replacing the temperature with 20. And so if t equals 20, I've got 2 steps to isolate d. I'm going to minus 20 and then divide by 25. And if I minus 20, I get 0. Divide by 25, I get 0 again. Which makes sense. I already knew that one, that the temperature is 20 when the distance is 0. We've seen that a few times. Now I would do it again, but this time I would replace t with 95 minus 20, that would get me 75, and then divide by 25 would be a distance of 3. So this time, if the scientists decided to study organisms between 20 and 95 degrees Celsius, that means they're going to study organisms between 0 and 3 kilometers into the Earth's crust. Here I've got a fashion designer that's ordering fabric that costs $20 per yard. So that's my 20F in my function. And they also want to dye the fabric, which costs $100. So C equals 20 plus F. C is my cost, and F is the number of yards. So if we want to figure out what their cost would be for 30 yards of fabric, we're just going to replace the F with 30. and do that calculation. So then I'd have C equals 100 plus 600, which means the cost for 30 yards of fabric would be $700. So here we're being told that they have a budget of $500. So what they're restricting is our cost. They're saying the cost could be as high as $500, or it could be as low as, we'll actually come back to that one for a second. Let's think about that. I'm going to pause there. But the cost could be as high as $500. Other than that, I'm going to spend less. So then let's figure out how many yards of fabric I would need to make the $500 happen. So if I were to take that function and replace C with 500, now I've got a two-stepper. So I'm going to minus 100 to get 400, and then divide both sides by 20, and then 40 divided by 2 would be 20. So if I were to spend my entire budget of $500, I could buy a maximum of 20 yards of fabric. Now normally we would think the lowest amount that we could spend is $0, and the lowest amount of fabric we could buy is 0. So what I would look at here is what happens in this function if f were 0. So if f were 0, what would happen is I would have 20 times f, 20 times 0, which is 0, plus 100. And so in this function, if you put in the number 0, you actually get out the number 100. But remember that 100 represents the cost of dyeing the fabric. So that doesn't really make sense. You wouldn't dye the fabric if you were going to buy 0 yards of fabric. But then that would make a question of like what would be an appropriate starting number? Would that appropriate starting number be 1? Would it be 2? Would it be 1/2? And so the way that we're going to fix this is, instead of saying f is greater than or equal to, remember if I'm like reading it backwards, I'm just going to say that f has to be greater than 0. So what this is saying, assume that I'm buying more than 0 yards of fabric. So I'm buying at least some. And that would mean that my cost would be greater than 100. All this part is trying to say is, for example, you are able to actually spend $500. You are able to actually buy 20 yards of fabric. You could have these two numbers make sense. But that, even though you could buy 0 yards of fabric, that amount wouldn't go with 100, even though when you plug it in here, that's what would come out. So we're going to say that we're at least buying some fabric. So f has to be greater than 0. Cost has to be greater than 100. So we're not going to actually let it equal those two numbers. Just a few additional reminders about functions. Remember that something is a function when each input x has only one output y. So if my inputs were like 1, 2, 3, 4, my output could be -7, 3, 2, and then it could be even -7 again. Because even though the input of 1 and 4 have the same output, they each only have one output. From a graphing standpoint, remember that one way to very quickly tell if something is a function is if it passes the vertical line test. So for example, a graph like a U shape, if I were to draw a vertical line anywhere through that graph, I could only ever make it intersect once. But if I were to draw a graph maybe like a sideways U shape instead, where it looked like this, now if I draw a vertical line, I can make it intersect more than once. And so that's just a quick way to tell that it's not a function, because that means, for example, these inputs right here, which happen to be the input of -2, have two different outputs.